So let's have a look at this molarity thing here. This is all you're going to have to do for today, concentration and molarity. So here's how it works. Let's hide that. There we go. We're going to skip past the quizzes, obviously. What is concentration? Concentration is just simply how much stuff you have packed into a certain amount of space. For example, yeah, that's a lot of stuff to pack into a very small amount of space. And there's many different ways of measuring it. For solutions, in general, you have the amount of solute, that's the stuff that you're dissolving, per unit volume of solution, like grams per milliliter or moles per kilogram or, whatever method of concentration you might want to have. And we're going to do two main types of concentration. We're going to do molarity today. And then next time you're going to do parts per million. And they're done differently, but it's still the same idea. It's the amount of stuff you have dissolved divided by the amount of stuff you're dissolving it into. So, yeah. So we're talking about molarity. Okay, now you don't have to memorize this, of course. Like all the other math formulas, you can find it on reference table T on the back of your reference tables. Concentration, molarity is equal to moles of solute divided by liters of solution. And what is the molarity of a solution that contains 4 moles of NaOH per 6 liters of solution? Well, this is easy peasy. All you got to do is molarity, capital M, is equal to moles of solute, which is right here, 4.0 moles of solute, divided by the number of liters of solution, which is right here, 6.00 liters. So we just substitute in those numbers, and then we get a number. Now, this has 2 sig figs and this has 3 sig figs, so we only want 2 sig figs in our answer. And so there we go. Now, we could report it as either being moles per liter, or we could call it capital M for molar. Either way is acceptable. Capital M is just a short way of saying moles per liter. Okay. Now, in this particular case, we don't have moles, we have grams, and we don't have liters, we have milliliters. So you guys know what to do when you don't have the units you want. Convert! So we molarity is moles per liter. So what we're going to do is we're going to convert first the grams of NaOH to moles of NaOH. So Na is 22.9, that's 23.0, and O is at 16.0, and H is 1.0, so that all adds up to 40.0 grams per mole. When you divide, of course, the grams cancel out, and 20 divided by 40 is 0.5. But of course, we have 3 sig figs here and 3 sig figs here, so we want to have 3 sig figs for that. So that gives us the moles. And those are the moles we're going to put up here for moles of solute. Okay, second, we're going to need liters. So we have milliliters, and there's 1,000 milliliters per liter. And by dividing, the milliliters will cancel and give us that. Now, you might want to just write 0.4, but since there's a decimal point here, remember, bigger than 1 with a decimal point, they're all sig figs. And so you want to make sure you have 3 sig figs here, and so you have 3 sig figs here. That's not a measurement, so sig figs don't count. Now that we have moles and liters, we just have to simply divide. So what we do is we put in the 0.500 moles divided by the 0.400 liters, and that will give us, well, let's see, 3 sig figs, 3 sig figs, 3 sig figs. And so we have 3 sig figs all the way, 1.25 moles per liter. By the way, if this was 40 decimal point, I'm sorry, no, if this was 20 decimal point, then this would be 0.50 and this would be 1.3. So just keep your rounding in mind. Okay, next example. What if you want to make your own solution? And why wouldn't you? If you're a scientist, you are going to make your own solution. So here's a solution on how to make a solution. You can either buy it pre-made. This is 0.5 molar sodium hydroxide. We only know this to 1 sig fig, though. We don't know what the concentration is past that. So any math we do with this solution can only have 1 sig fig in it. And that's not very useful to us. So what we need to know is how much solution do you need to get the job done, first and foremost, and then what concentration do I need to make this reaction work? And then how many grams of solute do I need to measure out to make this solution that I want to make? And I do this every single time I make a solution for your class. So what we do is we just rearrange the equation to solve for moles because we can convert moles into grams. We can't convert anything else into grams, but we can convert moles into grams. So we're going to multiply both sides by liters. And there we go. Moles times molarity times liters equals moles. Now, this is why it works. Molarity is moles divided by liters. So when liters cancel, moles equals moles. All right, so let's have a look and see how this is accessed. Okay, so to make a solution, what you do is you get a gadget called a volumetric flask, and it's got a little line up here. So if this says 250 milliliters, that means when it's filled up to this line, it'll have 250 milliliters of solution in it. If it says 1,000 milliliters, well, then you'll have 1,000 milliliters. And they make this in all different sizes. I've even seen them as small as 5 milliliters, and they're so cute. Okay, so what we do then is we weigh out how much solute we need. We use a balance for that. We put it on a weigh boat, and then we just put it into the bottom of the flask. And then we fill with water until we have the level up to the line in the flask, and then we'll have exactly the volume that we need. And so volumetric flasks are how you make solutions. It's really the only way to do it. So how many grams of potassium nitrate do you need to make 750 milliliters of a 0.100 molar potassium nitrate solution? Well, first, we're given milliliters, so we're going to have to get that into liters. So let's see, we have 750 milliliters. We'll divide that by 1,000 milliliters per liter. That gives us 0.750 liters. That's great. So we're going to solve for moles. Moles is equal to molarity times liters. So the solution we want is going to have a molarity of 0.100 moles, a volume of 0.750 liters. You see, when you multiply, the liters will cancel and give you that many moles. Now, since we have to convert this to grams, we need to look up the formula mass of potassium nitrate. So 39.1, because that 9 there bounces that up to a 1, 14.0, and 16.0 times 3, because there's 3 of these in the formula. And that gives us 101.1 grams per mole. And when you multiply, moles will cancel and leave you with grams. And just to check the rounding, 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, 4 sig figs, 3 sig figs. So what this means is we're going to take this potassium nitrate, we're going to weigh out exactly that much of it, we're going to put it at the bottom of a volumetric flask, fill it with water, and then we'll have our solution. Make sure the volumetric flask has a volume of 750 milliliters, though, because otherwise it won't work. Okay, and ladies and gentlemen, that's it. That is how to make this happen. So best of luck to you, and may the force be with you and all the rest of that. And I'll see you on the other side of this. In the meantime, I'm going to escape out of this. And how do I end this recording? How do I end this recording? Oh, there it is. It's right down here. So we're going to stop.
Bye.